Hello students, welcome you to this session. So in this class, I'm going to teach you probability, the second exercise. So here what you need, P of A plus P of A bar is 1. Then addition theorem. P of A union B is equal to P of A plus P of B minus P of A intersection B. Then mutually exclusive. Two events A and B are mutually exclusive, then A intersection B empty set. Probability of A intersection B is 0. Then P of A union B is equal to P of A plus P of B in the case of mutually exclusive, right? Then only A, probability that only A. So what's the meaning of that? Only A means, say this is A, this is B. Only A means this portion alone. So that is actually P of A intersection B bar. So this can be written as P of A minus P of A intersection B, right? From the entire A, you remove this portion, right? That is P of A intersection we have to remove. Same way, only B. P of only B. That is this portion. P of A bar intersection B. Outside A, but it is in B. And that can be written as P of B minus P of A intersection B. Okay, that also you remember. You can do the sums very easily. Okay, now let's see the first question. A and B are mutually exclusive. So read the question very carefully. A and B are mutually exclusive. P of A, they given us 3 by 8. P of B is equal to 1 by 8. Then the first subdivision, they asked to find P of A bar. Very simple one, right? P of A bar is equal to 1 minus P of A. So that is 1 minus 3 by 8. 8 is LCM. So 8 minus 3, it is 5, right? Now sum number 2, second subdivision, P of A union B. Second one, P of A union B. It is given A and B are mutually exclusive, right? So generally addition theorem is P of A union B is P of A plus P of B minus P of A intersection B. Here that part will be 0 because they said they are mutually exclusive. P of A, that is 3 by 8. Plus 1 by 8, 8 is LCM. So 3 plus 1, 4 cancel 1 by 2, or if you want you can write 0.5, or you can leave it as 1 by 2 itself. And see the third subdivision. Third question is P of A bar intersection B. P of A bar intersection B. That is only B meaning, right? So you can write it as P of B minus P of A intersection B. So P of B is 1 by 8. P of A intersection B is what? 0 because mutually exclusive. So your answer is 1 by 8 only. So P of A bar intersection B can be written as P of B itself when A and B are mutually exclusive. So in the fourth subdivision, it is P of A bar union B bar. So P of A bar union B bar. Here you have to use De Morgan's law. So this can be written as A intersection B the whole bar because you know A intersection B the whole bar is A bar union B bar. Now this is of the type P of A bar. What is P of A bar? 1 minus P of A. So this can be written as 1 minus P of. Leave that bar. You write A intersection B, right? That is 1 minus, since the A and B are mutually exclusive, P of A intersection B is 0. So your answer is 1 here, right? So now let's move on to question number 2. A and B are two events associated with a random experiment for which P of A given as 0.35, P of A or B, R means union, right? P of A union B is equal to 0.85. Then P of A and B, and means intersection. P of A intersection B, they given us 0.15. Now there are three subdivisions. The first one is P of only B. Here they didn't say mutually exclusive, nothing, right? Two events, that's all. Only B, so P of A bar intersection B, right? P of A bar intersection B can be written as P of B minus P of A intersection B. P of B, that is, we don't know, right? So what do you do? Using addition theorem, you have to find P of B first, then only you can do this one, right? So you have to say we have, write addition theorem. What is addition theorem? P of A union B is equal to P of A plus P of B minus P of A intersection B. One of the very important one, right? So substitute the known values, P of A union B. What is P of A union B here? 0.85. P of A 0.35 plus P of B, that is what we want, minus P of A intersection B is 0.15. Now we try to simplify. 0.85 is equal to 0.35 minus 0.15. It is 0.20 plus P of B. So bring this 0.2 to the left side. So 0.85 minus 0.20, 0.65, right? So you are getting P of B is equal to 0.65. So that value substitute P of B, that is 0.65 minus P of A intersection B is 0.15. So you are getting 0.50 or you say 0.5. Now see the second part. P of B bar. P of B bar, that is 1 minus P of B. So without P of B, you can't do anything, right? P of B, that's why you got it here. So to do the calculation very carefully, 0.65. 0.65. So how to subtract it? 1. 1 means 1.00. Then 0.65, you subtract, so 10, 9, 0. So 10 minus 5, 5, 9 minus 6, 3. So 0.35 is your answer. Now see the third subdivision. Only A, P of only A. Probability that only A. So that is P of A bar, sorry, A intersection B bar, right? Only A, P of A intersection B bar. So you can write it as P of A minus P of A intersection B. So P of A, what it is, 0.35. So 0.35 minus P of A intersection B is 0.15, right? So 0.15. So you subtract it, 0.20 or just to say 0.2. Now let's move on to the third question. A die is thrown twice. A die is thrown one time means it is what? 1, 2, 3, 4, 5, 6. A die is thrown twice. 2 dice are thrown, or a die is thrown 2 times. So you get that 36. Hope you are remembering. 10th standard also you have done many questions. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Then 2, 1, 2, 2 up to 2, 6, 3, 1, 3, 2, 4, 1, 4, 2, 5, 1, 5, 2. Then finally 6, 1, 6, 2 up to what? 6, 6 you will get, right? So this is what you are getting. This is the sample space for this question, right? So n of S is equal to 36. Now listen, let A be the event. A be the event. First die shows 5. Let A stands for first die shows 5. First die shows 5. So all these will come, right? So in this case you are getting 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. And B be the event that, B be the event that, see, B be the event that second die shows 5, second die shows 5, second die, see, second one is 5, right? So all these will come. So second die shows 5. So these 5 you will get. So what do you get? 1, 5. Second one is 5. 1, 5. 2, 5. 3, 5. 4, 5. 5, 5. 6, 5. Then A intersection B. So if you want, you can write here one more step. So B stands for second die shows 5. Then what is A intersection B denote? Intersection B, A intersection means and, right? A stands for first die shows 5, B second die shows 5. Intersection means both A and B. First one is 5 and second one is 5. First one is 5, second one is 5. There is only one such case. Okay, this one, that is the common portion, right? 5, 5, common for both. So A intersection B is only one, 5, 5. So what's the question they ask? See, find P of A union B. P of A union B, addition theorem on probability. P of A plus P of B minus P of A intersection B. In all the cases, denominator is 36. Numerator, you write the favorable. P A, N of A is 1, 2, 3, 4, 5, 6. So 6 by 36. B, 1, 2, 3, 4, 5, 6. Favorable case is 6. A intersection B, just 1, right? So LCM 36. So 6 plus 6, 12 minus 1, it is 11. So your answer is 11 by 36. Now let's move on to question number 4. The probability of an event A occurring is 0.5 and B occurring is 0.3. So P of A equal to 0.5, P of B equal to 0.3. These two given. See what they asked to find. If A and B are mutually exclusive, already the first sum we taught, no? So mutually exclusive, so you know what the results. Then find P of A union B. P of A union B, mutually exclusive, so the last term will be 0. You write only P of A plus P of B, so it is 0.5 plus 0.3, it is 0.8, right? See the second subdivision. P of A intersection B bar. So that is only A, right? So P of A minus P of A intersection B. P of A is 0.5 minus P of A intersection B, 0, mutually exclusive, right? So you are getting 0.5. And the third one, see what they asked here, third one, P of A bar intersection B. P of A bar intersection B, only B, right? So P of B minus P of A intersection B, that is 0, right? If you want, you write the step, actual formula, then you substitute. P of B is 0.3. So 0.3 minus 0, so your answer is 0.3. Okay, now let's move on to question number 5. Listen to that question carefully. A town has 2 fire engines operating independently. 2 fire engines operating independently. The probability that a fire engine is available when needed is 0.96. There are 2 fire engines, right? Say I'm taking, let A be the first fire engine, let A be the first fire engine, and B stands for second fire engine. So available P of A, the first fire engine available, the probability is 0.96. Probability of the second fire engine available is also 0.96. So not available you can find. Probability that the first fire engine available is P of A. So not first fire engine not available, that is P of A bar. 1 minus 0.96, you will get 0.04. Same way P of B, you know, from that you can find P of B bar, 1 minus 0.96, so that is also 0.04. Okay, now let us see what they asked. See the first subdivision. What is the probability that a fire engine is available when needed? A fire engine, so that is either the first fire engine or the second fire engine. So at least one is available, that is P of A union B, right? So one fire engine is available. So here actually you have to do so many cases. First fire engine is available. That means first fire engine is available, or second fire engine is available, or both available, right? So here P of A intersection will not given. So what you can do, probability that what they asked, a fire engine is available. A fire engine is available. What you do know, the P of A can be written as 1 minus P of A bar. That method you do. P of A bar means it's opposite. A fire engine available. What's opposite? It is not available. Not available. Not available means none of them is available. So 1 minus P of A is not available and B is not available. First fire engine is not available. Second fire engine also not available. Intersection means multiplication. P of A bar into P of B bar. So that is 1 minus, that's the reason we got P of A bar. So 0.04. P of B bar is also 0.04. When you multiply 1 minus 0.0016, you will get 4 4s are 16. 4 decimal places you shift. So do the calculation carefully. 0.9984 you will get. Now see the second subdivision. Second part is, what is the probability that neither is available? Neither is available when needed. Probability that neither is available. That is, the first one is not available and second one also not available. So can be written as P of A bar into P of B bar. First one is not available, 0.04, into second one also not available. So your answer is 0.0016. Okay. So 1 minus this answer gives you at least one engine is available. Okay, now let's move on to the last question in this exercise. That's a very simple one, very much related to your 10th standard portion only. The probability that a new railway bridge will get an award for design. So D stands for design. Getting award for design. The probability that it will get an award for efficiency. So E for efficient. Okay, let us write that first. Probability that getting an award for design is 0.48. Not getting an award for design, so P of D bar equal to 1 minus P of D. So you are getting 0.52. Same way for efficiency, probability of E is equal to what? 0.36. 0.36. Not getting for efficiency means 1 minus 0.36. So you are getting 0.64, whether we need or not, just you write. Then now read the subdivisions. If there is a need, you use that one. And one more given, and that it will get both the awards. So getting an award for design and efficiency, and means intersection, R means union, right? For both, getting an award is 0.2. 0.2. See the first subdivision, first part. What is the probability that it will get at least one of the two awards, either A or B? Okay, so A or B, but here it is D or E, at least one award. D union E. Addition theorem, right? P of A plus P of B minus P of A intersection B. Here instead of A and B, I have taken D and E. P of D 0.48 plus P of E 0.36 minus the intersection is 0.2. So when you add first and second, 0.84 minus 0.2. So when you subtract 0.84, 0.2, 2 means 20. Okay, like that you have to do. So you are getting 0.64. Sometimes in calculations we make mistake. Okay, very easy one. You should not lose any mark here. Second one, what is the probability that it will get only one of the awards? It will get only one of the awards. Probability that only one award. They didn't say only design. They didn't ask only efficiency. Only one award. Only one award means one getting award only for design. P of D intersection E bar. Getting award for design and not getting for efficiency. R means plus. Not getting award for design but getting award for efficiency, right? First one is only design. So P of D minus P of D intersection E. Second one only efficiency, only E. P of E minus P of D intersection E. P of D is 0.48 plus P of E I am writing. P of E is 0.36 minus 2 times P of D intersection E, right? So if you add these two, 0.84 minus 2 into, getting for both it is 0.2, right? So 0.84 minus 0.4, so your answer is 0.44, okay? So hope you understood all these sums. Try to practice the questions, example sums, everything. We'll continue the next video.